can create a policy where every user has a private folder on a street where only they can upload. But this upload can trigger a Lambda function that will extract information here. And when you upload the pictures, you can put with S3 also custom metadata in the object, like the author of the picture, the location where the picture was taken, so that the GPS location of the phone can be embedded in the picture, a description of the picture. Any metadata that you can think can be added to the picture itself. The Lambda function can, for example, extract some information from this bucket, and can check, for example, write this information in a bucket usage table, where all the pictures uploaded by all the users are stored with the size of the picture. And this can trigger another Lambda function that can check all the storage that has been uploaded by this user. Maybe it can be also just a counter for the user. And if the user is gone beyond its own space, maybe 3 users have 1 gigabyte of space, 3 users they have 10 gigabytes of space, the Lambda function can delete the content from the bucket and can send a notification using Amazon SNS mobile push straight to the phone. The classical notification you receive, hey, your picture has been deleted because you are not authorized or you are beyond your space. But you can attach more than one Lambda function to a S3 bucket using, for example, SNS. And in this case, this Lambda function can extract the metadata of the object, like the author, the position, and everything, and store this in a media metadata table where all the metadata of all the picture is stored. And this can trigger another Lambda function that updates the user statistics table depending on the content that has been uploaded by the user. And now you can create another Lambda function that is exposed via the gateway. That is a text API where from the browser you can get information on any user that is maybe a friend of this user to know which picture this user has uploaded. So you can create an interface where you can navigate the pictures, and maybe you get the link of the pictures, and then the user can download the pictures from a screen straight from the mobile app. And maybe if the user is okay and uses consent, you can send the location of the users every 5 minutes. Something similar to what we experience with application like Foursquare. So what happens is that every 5 minutes you send the location of all your users via Kinesis. Then there is a Lambda function that is consuming this information in batches. Will update a user location table, then you have a user where they are in the world. And this can trigger another Lambda function that will look for users, or pictures that are closer to this user. And if there's something relevant, like oh, you are close to a picture shot by your friend, can send an SNS mobile push notification to the device saying to you, hey, you are close to this text. Similar to what happens with the place application that tells you where you are close to something like that. And you can also expose this information via an API gateway, so that the application can maybe check the location of your friends and see and know if some of your friends is close to you. And maybe you can use the Amazon Cognito Store to rate the pictures of your users, of your friends. So you can give a star from 1 to 5 to all the pictures that your users share. And a Lambda function can consume this asynchronously because this is local to the device and can be uploaded sometimes when there is network connectivity. And when there is network connectivity and you receive this information, you can log this in a table and maybe you can send whatever you want, like notification to your friends that your picture has been rated or something like that. So we really built a complete application without any server, and the cost of running this application is very, very low. So it's close to 0 unless you have thousands and thousands of users who are probably consistent. Another nice point is that we were automatically brought to write small components of code. We didn't write a lot of complexity out of nowhere. And all these small components are bringing you in the right path to adopt microservices. Of course, there are other requirements. There is no clear definition of microservices, as we said, but this architecture is going in the right path. You also, there is this eternal debate in programming, choreography versus orchestration, what is better. Here you are giving a, I would say, a bottom-up choreography, because from the components you are telling what the logic should do, instead of building a top-down orchestration where in a central repository you have all the logic of your application orchestrated. And this is making a lot easier to introduce a new feature. If you that writes in a for example, in a database table, automatically all the functions that consume the updates are triggered, and you don't need to change the logic. Because if someone from another process is updating the location of a user, automatically all the logic that you are connected to the table that is looking for friends that are close to this user will be triggered. It also brings you to thinking in the way of reactive programming. So I invite you, if you didn't to have a look at the reactive manifesto, to think about asynchronous communication among software components, because that's the key to build distributed services and distributed architectures. And also, on a programming perspective, it has some downfalls. So you have to think that now data is distributed, it's not in a central repository anymore. So you have to think of eventual consistency. Something is updated, it's not immediately visible when you do everything. So you need to think that your data is not consistent everywhere, but it can be updated with some lag. But this is something that should be clear to everybody developing a distributed application. But the problem is that a lot of people, they start with a local deployment, and then when they go in production, they discover that time exists and not everything happens at once. So let's see a short demo to give a better idea of how everything works. Can you see this? Okay. So this is the AWS console. We saw it before. Let's go on the AWS Lambda console. So in the compute section, we have Lambda. And let's create a Lambda function. So get started. So what's the first program that you would write in any programming language? Hello world. But since here we have functions, so we have to give something and get back something, we do something more complex. So this is a list of blueprints that we already give. For example, if you want to build a Slack bot, there is a Python example that you can use to build a Slack bot. If you want to consume kinesis, there's an example of how to consume kinesis. I skip this because I want to create a greetings on demand function that will greet me by name when I give the name. So give a name and you will be greeted. I can choose the runtime here. We currently support a lot of JS, Java, and Python. We are looking to extend this for adding the other languages. But you can bring any binary with you. So this function can also be just a wrapper, and then you can bring any binary. There's people running Go static binaries using a Node.js wrapper, for example. So for this example, I will use Python, and I have the very basic function here. And I can paste the code here. You don't need to paste the code here. You can upload a zip file, with especially if you have dependency like modules in JavaScript or in Python that you want to bring. And you can also use create and update a Lambda function from the SDK or from the command line. So the web browser is an example. You can do everything from the command line. You will probably do that in production. So this is an example. I have some code before of the function that is just importing a JSON module. But here you can, for example, do anything that can be reduced for the same invocation of the function. Because when we execute the function for you, we will create a Linux container. And this Linux container will start, execute this code, and then it will iterate on the Lambda function. So if you have some, for example, a database connection to create, you put the database connection here. So it's reused by all the other invocations. If you need to load some data from a central repository to cache it, you put it here, and it will be reduced by all the other invocations. Then there is a function that you want to expose. You can have multiple functions. You have to specify which one you want to expose. And this function will receive an event that can be something. If you have a direct invocation, like now I want to give a name, it's something that you define. If this event received by Amazon S3 or DynamoDB, there is a specific syntax that we provide to structure this event. And a context. For example, if you use you know which HTTP methods have been executed. And then you have your code. In this case, I log the event. Everything that you print is logged centrally on CloudWatch logs. And then if there is a name in the event, I take the name from the event. If there is no name, I use word as name. And then I build a greeting that is hello plus the name. And I print it, so that it's logged. And then I return the greeting back to the user. So it's nothing very complex here. Now that I have the code, here I need to specify the name of the file. So let's zoom a little bit. the name of the file and the name of the function. So since I'm using the console, lambda function is the name of the file. But if you have talking locally with multiple files, this is the name of the file inside the zip code where to look for the function without the Python or Node.js extension. And then the name of the function is inside this file that will be triggered by lambda. So you can have 10 files, hundreds of functions, only one will be specified here. Then you need a role, because as the users that come externally, everything on AWS is controlled, so you can access resources. So in this case, the only role you need is the capacity to write on CloudWatch logs, to write logs, otherwise you don't have logs. And we provide a basic execution role for you. So this asterisk is automatically inspecting your code and suggesting you the right role, but you can create more complex roles. I already have this role created. Now you have to choose how much memory you want to give to this function. And memory is affecting price. So when I was saying 3.2 million of 3 seconds of execution time, it's with the smallest amount of memory, that is 128 megabytes. That's a lot if you don't need to do strange things. But you can choose up to 1.5 gigabyte of memory. And if you give more memory, you also give more CPU power, because it's linear. The container will get more I/O and more CPU power. So if you need a function to go faster, you can increase the memory. So if you double the memory, you will pay double the cost. But if the function will run in half the time, at the end it doesn't change for you, because you pay by the time and by the memory. So 128 megabytes is okay. Then you have the timeout. This function runs in the background, so we don't want you to launch a function that will run for 1 year and you discover after 1 year that there was a function you have to pay. So every function has a timeout. The default is 3 seconds, but you can increase it up to 5 minutes. But you don't want to have long-running batch job with lambda. 3 seconds is more than enough to say hello world, so I can leave it here. Last point is the integration with the VPC. So this is quite technical for AWS, but in AWS you can create your own private data center. It's called VPC. So if you have your own private data center, you can say this function must be executed in my private data center. So if you have a database there, like an Oracle database or a MySQL database, then the function can connect to the database privately without going to the internet. For now, I choose login. This is a classical recap, and now I create the function. It took some time, but actually it was just for explaining how it works. And now that I have a function, here I have the test button, and I can test the function. So when I test the first time, it will ask me which sample event should I send to the function for testing. Here in the menu, I have all the standard events from S3, CloudWatch, the API Gateway Authorization, DynamoDB. But in this case, I have to create a custom event, because we only want to give a name. So let's say Danilo. So this is just a JSON object with only one property, name Danilo. Now I save and test. Now the function is being executed, and as you expect, we'll get as a return hello Danilo. And here we have some more information. So we have the access to the log of the function. So we have the received event that has been logged, the output before returning. And you also see how much time the function took, 0.2 milliseconds. So you pay by the hundreds of milliseconds, so this is probably not using very effectively, because the build direction is around 100 milliseconds. And of the 138 megabytes, we use 24. That's probably the minimal usage of the Python interpreter. All the same information is also here in a nicer format. Okay, now we have the function. I can change the test event. So let's try to give an empty JSON object. What should happen now? Hello world. Let's see. Okay, we get an hello world. Okay, so now we created this function. It can be invoked once per month or 10,000 times per second. I only pay for the execution of the function. I don't have to manage availability, the scalability, the fetching of the operating system, of the Python interpreter. Everything is managed by us. But I want to use this function. So I can create an API endpoint from this function very quickly from here. But since I'm a very boring person, I will go through the Amazon API Gateway console to show you how it works. So here in the application section of the console, we have the API gateway. I'm using Frankfurt as a region.
Say I want to talk with database with that, for example. Do I have to code the information inside the function? Or
So if you want to connect to a database like Django, the name of the table, for example, should be in the function. It can be passed, for example, via the API gateway to a variable, so that the same function can use in development, where the table is maybe has different name than production. And for connecting to other AWS resources, you need credentials. So the role that we saw can also give temporary credentials. So in the role that I gave a basic execution role only to write logs, but you can create a role that says, okay, this function can write in this DynamoDB table, and then it's completely transparent to you because the function will get temporary credentials and use them without any explicit code on your phone inside. If you connect to an external repository that is not managed by AWS, you have to put the credentials somewhere. You can put them inside the function or via variables. And we also have an encryption SDK that currently is available only for Java that can use our key management service. It's a service that can manage keys. It's using a hardware secure module for storage and anti-tampering in the machine, so something that's really secure. But if you have a compliance and you don't want to put password in clear, you can use this. But this is only for Java APIs for now. So now we are on API gateway, and let's create our first API. So I call it my greeting API. Hello. And this is an empty API. It doesn't do anything for now. It's still being created. Okay. And this is those are the resources of my API. At the beginning, you have slash, and then you can add resources asked for every web API. First thing that I do, I create a new method. A new, I call it greet, and it's automatically mapped to /greet. And now I create the resource. Now I can attach a method to this resource, and I have the choice of all the standard HTTP verbs like get, put, post. For example, let's use get, that is the simplest one, and I approve. And now when I do get on /greet, I have to define what happens in the backend. So I have to define the integration time. So as I said, you can use an HTTP, the gateway as an HTTP proxy for your own APIs. You can use it to build a mock integration. You can also use it to be a service proxy to another AWS API call. This is a strange use case, but sometimes you want to protect an API call, and the gateway can do that. The most normal use case is that you just map this resource and this method to an API, to a Lambda function, as we did in the bookstore example. You choose the region, it's the same region. The name of the function. I created the function with a very bad name, greet. Now I realize that I was. So let's use this function name, greet. You need to authorize the API gateway to call the function. Everything that I do on the web can be done by command line. It's just I'm using the web for the example.
Is this authorization creating any security group?
No, the security groups are not involved here because all the authorization are roles to access API calls. So here you are authorizing the API gateway to invoke the Lambda API for that specific function.
So
On your API.
This guys for now just created the Lambda and the API gateway endpoint, and if I browse around my AWS call, I don't get anything else.
No, you don't see anything because there are servers here, but it's not servers that are managed by you. It's really. So now I have the integration that we saw before. So from the client, I go back, I call the greet function, and I get the results back. So we can test the function. If I click here on test, as you see, I have no parameters because the API gateway doesn't know that there is a name parameters. It doesn't know that there is a function. I can test the integration, and I get an error word. So let's say that we want to tell the API gateway that there is a name parameter. So here on the method request, I can specify which parameters I want to send, and also the authorization if I want to limit the public access to the function. In this case, there's also the concept of API keys for developers. I'm not talking about that now. So you can send the parameters as an URL query parameters here, because this is a get, or in the headers in the HTTP headers. In this case, I use a URL query parameters, and let's call it name like the parameter. So now and here you see I can flag this for caching if I want to cache, to include this in the cache key. So now if I go back on test, I have the name, I can put Danilo, but unfortunately I still get hello world because I still have to teach the gateway how to use this parameter to pass it to the backend function. So and I can build mapping parameters. I can add one. I use just. And per default, I have an input pass through. So that means that the payload of the call goes through. But this works with an HTTP post, where the payload is in the call itself. For I get parameters, I have to do my own mapping. There is the concept of models that I'm not entering into, but if you have the same data model in multiple calls, you can create a model with, for example, a book as an author, an ISBN, a number of pages, and then you can use these models to simplify the integration. For now, I have only one parameters. So what I do, I use this very basic integration. And it's basically building a JSON object. Let's zoom a little bit. Just an object name with name, and as name I get the input parameter with the same name. This syntax is actually described in the the movement. It's described here. We have a section in the documentation when you have the context, the input, all the variables that you get from the API gateway. So the input variable, so in this case you get the parameters. Here you can get the whole key value store of the parameters here, and this is interesting because you don't need to teach the parameters to the API gateway. All the parameters that are sent are just sent as key value map. Or you can navigate the parameters using a JSON path syntax. So now I save this. We can go back to testing with Danilo, and if I didn't make any mistake, hurrah, we get hello Danilo. So what happens now if I remove the name? Hello world, let's try. Oops, you get hello exclamation mark. Because my integration was very basic. In my integration I was saying, take the name parameter, it can be empty, and I pass it here, so I pass an empty name and the function will print. The function was looking, if there is a name parameter, then use it. So this is an example of integration, and it's stupid, but it's interesting because sometimes the people managing the Lambda function and the people working on the integration are different teams. So if I want to make a change request, say, okay, if I pass you an empty name, don't print it, it can take weeks. So what I can do, I can build a smarter integration here and don't change the function logic at all. So what I can do, I can use this example that I have here. So I click here. And this template, it's defining a variable because I'm lazy, so I don't want to repeat input parameters more than once. So I create a $name variable, Then I have this if, then if, and block that is depending on the variable. So if the variable name is not empty, then write this. Otherwise, this block is not executed, and you only have the empty object. So this syntax may be familiar to you because actually this is a velocity template. So all the velocity templates works, and you can use the standard Apache velocity templates plus the variables that we populate for you. So it's standard here. So I guess I save the new template. I can back to test my function. Let's test with an empty value. And now we get a word with a self. Actually, we get a hello world, but we get a JSON content type. So this is not very correct from an API point of view. So we need to change something here. So I can change the content type to be text, but I can just format the output of my function to be JSON. So what I can do, I go back here in the integration response this time. For the 200 so for the normal execution, I can use the same syntax to create a mapping template. Now I have a pass-through. Everything that comes from Lambda, I just pass through. I can click here, select a mapping template, and I have basically the same syntax as before. So in this case, I create a JSON object with a greeting, and then this input dot path is a JSON path of the answer, and dollar means the root. So basically, everything that is returned, I just put it here. This is also useful if you have like HTML code or something that needs to be URL encoded, because this will respect the syntax and the encoding. Otherwise, you can get strange results if you have something that must be encoded. So wrapping everything in JSON is always good in this kind of scenario. And now I can save this, go back to my test, and finally I should have something correct, because I get now the greetings wrapped in JSON with the JSON content type. So we build our own API here. So this is a very basic example, and the nice part is that this function can be used also on the web. So now I can deploy my API to use it externally. So I click on the deploy button, and API Gateway has the concept of stage. So you can have an API in different stages, for example, production, test, and development. Or if you break the compatibility of your API, you can have version 1, version 2, or version 3. So let's create a new stage, because there isn't any. Let's call it prod. And this will be my production stage. I can deploy here now the function. And now, if I see now I'm in the prod stage, if I click on get, I get the URL of my API. Now it's publicly available. I didn't set up any authentication, so you can quickly write this in your mobile phone. Of course, you can customize your domain and make it more usable. And then you have the stage, prod, and then you have all the resources that you can create. So for example, now I can click here, I copy this link, I go here, I paste it, and I should get a beautiful hello world. And if I add here a name Danilo, I get hello Danilo. So the API now is available, scalable, distributed by the content delivery network, and the execution is managed by Lambda, so I don't need to think about scalability or availability. So let's say that now I want to make a change to the API gateway. I don't want to put the name parameter, I want to put as a URL. So I can go here, and under the grid, so I go back on the resources. Under grid, I can create a new resource that is, for example, let's call it a username. And instead of being a fixed resource, I use the curly brackets to say that this is a parameter. Now I create the /grid username resource. Okay. And now I can connect an API call, backend call here. So, for example, I use the same method as before, the get. And I want to use the same Lambda function as before. The green function. I authorize the users of the call. And now if I go in the method request, I find that I have automatically a request path as parameter, and it's called username. So I can now build the integration as before. I have an mapping template. It's still JSON. And it's not an input plus true, but it's mapping template. And this was the integration I used before. Do I need to change something here? Username, exactly. So now the input parameter is not name, but it's user. But still, I pass a name to the function. So I only change this part, the name of the parameters, but it's with. And of course, I can use the int then as before, but it was just to test something. Now I can test the function with any name and quick, and the function works at the time. And I can deploy again the function. Now I can deploy in a different environment, or I can deploy in production. So I go through for example, let's create a new stage, test stage for testing. And this is the new username. So now I have two stages. In production, I only have /grid, and in the test environment, I have /grid and /grid by username. So I can click here, copy this link, and here I can read. Oops, I don't know what I did. Do that. I can say John just to test something different. And I have another John. So the URL, as you can see, is now /test/big/John. And if I want to put this in production, I can go here in the stage. I can go in the deployment history of the stage. So I go in production, I go in the deployment history, and I see that there is the first deployment where I forgot to put any description, and then the deployment with the description. Then I can say, okay, I want to move this deployment in the production stage. So now I'm going in production with /grid/username. And of course, this is an API call, so you can automate this moving in production using the online interface of the SDK, so you don't need to use the best interface. I noticed that you need to reload at this time, otherwise on the left it's not updated. But production, the /grid username. Okay, so we saw a lot of things. Let's wrap it up a little bit. So I think that building application in this way, without any server to manage, without managing scalability, is really interesting for developers. You are automatically brought to bring small functions that react to changes. So you are distributing your logic in small components, and you are reacting to changes, not managing a centralized workflow that needs to keep all the logic in a single place. So you can focus on your ideas, and as I said, you can start for free because Lambdas get hugely here, as I said. The gateway only for the first year, you have a fit here. I think it's 250,000 calls per month for 1 million. I'm not sure, but it's still a lot for development. So you can build an application without any cost, and then if you grow and scale, I think everybody will do that. Thank you. Any question? Let's start here then.
So how do we mock all this stuff while developing?
You can mock at the gateway level if you need the gateway.
Let's say that I'm in a plane, I don't have an internet connection, and I want to prepare all my logic to be able to get at the end of my flight ready to deploy to the AWS.
So for the gateway, it really doesn't make sense because it's going to expose it publicly. For Lambda, there are a lot of tools, open source tools, that allow you to execute Lambda function locally. Actually, you can write your own tool very quickly because you just need another like Python or JavaScript file that calls the function, and you need to pass the event that will be your
For
event.
sure, I can run my API as well, but
No, but there is no, it's just calling the function. There is no dependency at all. So you need another file because you don't want to do anything in this file that just imports the file and calls with the event that you have. And there are tools that already do that. It's not developed by AWS, but you can find open source tools to work locally with Lambda, with Python and JSON. I think we are, as AWS, also looking at how people are working because it's something new. Even though Lambda now it's 1.5 years that it's out, but it's always changing. There is people that build complete frameworks on top of Lambda, like the serverless framework, You can find it at serverless.com. It's a complete web framework that you can use to build a website with an approach that is closer to what normal developer has in the JavaScript framework, but you use Lambda passing the API gateway transparently. And there is like a company that did this for, it was a popular musician, I don't remember the name, that was launching the new record, and they built all the website for the launch campaign using Lambda, and at the end they paid something like $2 with over the infrastructure of the launch of the new record of this guy, so it's quite interesting. Of course, you don't have everything locally, but there is another point. So when you develop locally, you forget that time exists. Then when you go distributed, you have bugs that you didn't think that were there. So the fact that here you can develop locally with some tools, but you are forced to have the mindset of working with a distributed environment, I think this value is maybe balancing the fact that you cannot have everything locally. So you would have
I know that once you do your first project and you fail because of time, and then the rest of your career, you cannot keep that in mind.
Okay, but I can think that this is a feedback that we get. We are looking at what can help developers work better, but it's also us between what we line up now. For example, for DynamoDB, we use local DB that you can use for development. For S3, there are so many tools that we didn't develop anything. With Lambda, now we are seeing a lot of tools that are out, so we are not in ourselves, but we are looking at what can help our developers better. There was one question here, I think. Yeah. And then just to preserve the order, and then we go back.
Can you use external libraries with Lambda? External libraries, like if I want to import some external library for that Python example, how do I do that?
So if you have any dependency in your code, like modules or stuff, you can bring that with the function with a zip file. If you need to invoke external APIs like GitHub, you can do that from Lambda.
So like installing external libraries and then using them inside code. For example, we use pip in Python to install a lot of stuff. How would you do that for Lambda function?
So what do you need to do?
For example, request library in Python. We want to install
no, you do the request before uploading the function. So basically what happens, we have some description. So with Python, we suggest to use virtualenv, install all your modules locally, and then you zip everything with the dependency and ship that. And this is also following the right path for microservices, because with microservices, you want to bring the libraries with the microservices, you don't want to create dependency outside of the function. And it's also making faster for us to deploy the function when you go in production. So you need to, this is something that you can make automatic, so you don't need to do that manually. But the idea is that you install everything locally, so with Java, you have all the jars, with NPM, you install locally for JavaScript and Node.js. With Python, you can either install locally with Git, or even better, use virtualenv and then zip the environment and send it to the function. And you can do interesting things. For example, I don't know if you know OpenCV. It's an open computer vision library. It's completely based in C++. So what I did, I looked at the Lambda execution environment. So in our documentation, we tell you which is the image, so the operating system that we use to execute your Lambda function. I started this image. This is an Amazon machine image. So you start it. I compiled the OpenCV locally, and then I shipped it with a function. And I created a function that is using JavaScript or Python to use the OpenCV framework. And then you can just send a picture as a, so in this case, the input parameter is a URL of a picture. It will apply face recognition, and it will return a picture. Actually, Lambda is better not to return binary content, so what I do, I write in a temporary folder on S3 the output picture, and then I return the link to the picture. And then I have another Lambda function that every hour deletes the temporary pictures that I have to take. And then you can put any picture here, or the URL, and Lambda will do the analysis and return. So the return of the Lambda function actually is the URL of the picture and the number of functions. This is an example of, I didn't strip the library at all, so it's 20 megabytes. but you don't pay for the storage of the function. Every user has 75 gigabytes of space for free for hosting Lambda function in every region. And the idea is that you should create the dependencies. Every time you upload a new version of a function, you put all the dependency with the right versioning inside the function. You can test it and then maybe push functions so that you don't break the dependency. I didn't show this because of time, but in Lambda, this arrow here is actually opening the version tab. So when you update a Lambda function, you can create a new version of the function. And you can have version 1, version 2, version 3. And then you have aliases. So automatically you have the latest alias that is linking to the latest version of your function. It's the one that we execute. But you can specify a specific version of Lambda if you want. Then you can also create aliases, like you can create for a function the production alias that goes to links to version 3. And the test alias links to version 5. And then you can just update the alias. So in your API gateway, you say, in production, I want to call the function with the production alias. Then you take the production alias and you say, move the production alias from 3 to 5, and all the reference to this function will automatically execute the new version of the code. So versioning is managed by the platform. It's a little bit tricky, so I didn't show that before, but it's a nice feature. Versions are not created automatically because you can update a function a lot of times. So when you create a function, there is a flag to say, okay, with this update, create a new version, and then you have the new version.
Last question. So this paradigm won't work for threads. For example, if I want to have a lambda function that spawns thread, doesn't upload on S3 and returns, but it returns before doing the actual upload. It won't work for
the function can return. So when the function returns, the container is freezed. So you cannot execute other code. So the return of the function that should be the last thing that you do. But you can call function asynchronously if you want. So you still pay for the execution time, but you don't need to wait for the return. So I did an asynchronous example with the return code, but you can call a function asynchronously. In that case, when you invoke the function, the invocation terminates immediately, and then the function can run from 1 second to 5 minutes, and then you pay for the execution time. When the function ends, the container is freezed, but you don't have the return. And from a synchronous Lambda function, you can call a synchronous Lambda function, or vice versa. So you can tie multiple functions together if you want. So this was the.
So you added the code there, but can I control the code with a version control system like Git or something like that?
Yeah, so you can put the code anywhere, and then you just need to use the command line interface to push it to Lambda. So for example, we have a command line interface that is AWS, that is used for most of the services. Then you have AWS Lambda, and this can call basically the API call that you have. So in this case, you have the most important one are create function here, and then you have update function call and update function configuration. So what you need to do is a very basic script that when you want to go in production, can use these calls to update. A lot of users are using Lambda functions to deploy Lambda functions. So for example, with Amazon S3 buckets, you can activate multi-region replication. So you have a bucket in Europe, everything that you put there is automatically replicated in the US, or vice versa. So what you do, you connect a Lambda function there, and when you upload the zip file of your function, you have a deploying function that takes this and deploys the function in the region. The replication will bring the zip file in the other region, and another function will deploy. So you can create a continuous deployment multi-region with just a single Lambda function that does it. I think I'm running a little bit out of time, but for any other question, I'm available here.
Any questions in there or some hands over there? So please, let's go directly to Daniel. Thank you, Daniel, for these exciting sessions. Appreciate your time. We have our last two sessions today. One of them is here, the other one in the breakout room. So please welcome all guests. And the name is very, very difficult. Kika is going to speak about what make an introduction for us about Azure. Azure Test Lab. Complete concept.
I hope you enjoyed it. In the other room, the breakout room, I'm going to have something about 3D in browser, how you build a website in 3D. So enjoy the work. Thank you a lot for that.